Stanford University.
Okay, welcome to Stanford CS193EP. This is our second lecture. We are going to go through today a little more of how MVC gets applied to a real project, okay, the calculator project. We're also going to learn our first glimpses of Objective-C. I'm just going to show you a little bit how do we declare a class, a little bit about what code looks like, sending messages. But next week is the real in-depth teaching you the entire language. So today is a little bit just a taste. We're also going to look at Interface Builder, and this is the tool that lets you graphically build your view. If you think of the MVC, this lets you graphically do the view part and graphically wire it up to your controller. So we'll be looking at that in a little bit of depth there. And then we're going to look at Xcode in quite a bit of depth because we're going to go through the process of building an entire project from scratch to finish. So we'll see a lot of Xcode today. So I wanted to start by going back to the MVC slide we had before and show you on this, in this picture, this kind of graphical image of MVC, what we're doing today. So you remember that there's all these different kind of connections, and we're only going to do a small number of them today because we're building our first application. And these are the ones we're going to hook up, okay? So we're going to have a model. Our model is going to be called Calculator Brain. We're building a calculator. I think I've said that, but we're going to build a calculator. So its model is going to be the brain. Now the brain, again, won't talk to the user interface. All it knows how to do is operations on operands. That's all it does, okay? So that's going to be our model. We're going to have a controller. The name of that class is going to be Calculator View Controller. Okay? The iOS SDK uses the term View Controller for the controllers because it doesn't want to confuse them with some controller you might have in your model that's controlling something in the model. So View Controller, when you see a class, something View Controller, that means a controller that is controlling some view in the iOS SDK. And then we're going to have a view. Now, the view is not really, there's no single class for a view. In fact, our view that we're building for our calculator, it's going to have a little display that shows the output of our calculator. It's going to have some operation buttons, plus, minus, times, and some numbers, 3, 2, 5. And we're going to build that all graphically. We're not going to write any code to build that whatsoever. Okay? And it's all going to be bundled up and stored in a file called a nib file, or some people call it a zib file. And so we're going to show you how to do that as well. Now, we're also going to, in addition to creating these three things in Xcode and Interface Builder, we're also going to wire them up. So we're going to have one outlet. Remember, outlets are when the controller wants to talk to its view. So we're going to have one outlet that talks to the display, because every time we do some operation in the calculator brain, we need to update the display with our new value. So we're going to need that outlet. And then we're going to have a couple of these actions. We're going to have one action, digit pressed, colon, and another one, operation pressed, colon. And they're going to do what you would think. When you tap or touch on a digit button, it's going to send digit pressed to the target, which is going to be our controller. And when you tap on an operation, it's going to send operation pressed. Okay? So that's what we're going to do today. Hopefully, you can keep this image in mind as we do the actual coding, so that MVC model and approach to designing solutions will fit into what you see. Now, I'm going to show you the Objective-C of a little bit of what we're doing beforehand, both so it's documented in my slides online so you can go back and look at it, and also so that when I get into it, I can focus more on the flow of the tools and how we go around and not have to stop and be explaining the syntax of Objective-C. So this file we're going to look at first is our models header file. Okay? Remember that all the classes have header files and implementation files, and the header file is the public API. All right, so it's a little different than like Java, more like C++, where you have a separate file, your header file, for your API. So the primary syntax in the header file is this @interface @end. We put everything in the declaration of our class between that. On the @interface line, we put the name of our class. So this is our model. It's going to be called Calculator Brain. And then a colon, and then the superclass. Now, our superclass of our model is NSObject. Pretty much all objects in iOS inherit directly or indirectly from NSObject. It provides some kind of basic functionality, memory management, a couple other things that we want to inherit in all the objects that we use, okay? So that's the name of the class, and this is the class's superclass. Now, if we're going to put that superclass there, we need to import its header file. Now, the header file for NSObject is actually a framework include called foundation. So foundation.h has all the includes for what's called the foundation framework. Foundation framework includes NSObject, but also arrays, dictionaries, all that. We'll be covering that all next week. Very important framework. Then your instance variables go here. Okay, all your instance variables go here, even your private ones. Okay, now we're going to talk a little bit about instance variables and their publicness or their protectedness or their privateness later, but all instance variables go here. There's no way to hide an instance variable from somebody who's looking at the public API of your class, which is a little weird and takes some getting used to. By default, most instance variables are protected. Okay, they're essentially private. Whoever's using your class, they can call your public methods, but they can't access your instance variables. So our calculator brain only has one instance variable, which is its operand, its internal operand, or at least it's going to start out that way with only this one instance variable. Notice it's a double, okay, double precision calculator. And then our method declarations for our class go here in this space after the instance variables and before the @ end. And we're going to have two methods for our model. One is to set the operand, and then the second one is to perform an operation on the operand. And it's actually going to return the updated operand just as a convenience to have fewer methods and to make it kind of simpler. Notice that the set operand method, its return type, the kind of thing it returns, is void. Okay, that means it returns nothing. This is different than just not putting that parentheses there at all. That means something different. That actually means it returns an object. So if you have a method that returns nothing, you need to say parentheses void as the return type. Notice the other one is parentheses double. It returns a double. Okay? This is the name of this method. Set operand colon is what we would say. Some people might say it's called set operand, but usually if it takes an argument, we say the word colon when we're saying the name of it. And I'll show you in a second what happens if it has multiple arguments, because it's kind of funky. Definitely not what you're used to. This is the only argument to this method. It's a double. Okay, it's called an operand. That's just going to be the name of the local variable inside our implementation. Since this is the header file, you could really call that anything you wanted. Again, only one argument in this method. Don't forget to put a semicolon at the end of this. Just like in any other C-based language, semicolon is the end of this line. White space generally doesn't matter in here, although there's some places where it matters, and we'll talk about that later on in the quarter. So this method returns a double. It takes as an argument this ns string star, so it actually takes a pointer to an object as its argument. That's what ns string star means, a pointer to an ns string, an object of class ns string. And we'll talk a lot more about how we pass objects around. All objects in Objective-C are allocated on the heap, so you always have pointers to them. There's no way to allocate them on the stack as a local variable or any of that business. They're all allocated out of the heap. This argument called operation, again, doesn't really matter in our header file. So here I've thrown in a wacky method. This is not part of our calculator brain, but I just wanted to show you what it looks like if you have two arguments. So this method has two arguments, and it would be called foo colon bar colon. That's what people would call this method, foo colon bar colon. Not foo bar, foo colon bar colon, okay? And the first argument, notice that the arguments like zap and pow are interspersed between the names. It's not like Java or C++ where you have the long name of the method and then open parentheses and then all the arguments separated by commas. Okay, the name of the method and the arguments are kind of interspersed. The reason Objective-C does that is because the goal when we write good Objective-C code is we want it to read as close to English as we can. Okay, so we want those argument names, the name of the argument like foo colon, to match up with the thing we're passing in a readability way as we read left to right. And you'll see a lot more of this as we write more and more code, why this makes sense. It's actually kind of nice. This one returns a pointer to an object, an NS array I've just made up here. Okay, so that's a pointer to an NS array. It is possible for these pointers to be nil. Basically, there's a keyword in the language, nil, which means there's no pointer, basically a nil pointer. Dereferencing a nil pointer by sending a message to it does not crash your program. So that takes some getting used to. Okay, so it's not like a void pointer. It's a little different than that. Notice this second argument, its type, ID. See that type? That's a new type. That's Objective-C only. That means pointer to any object. So you can pass a pointer to any object. You could pass a string in here, an array, etc. And you might say, whoa, wait a second, that's pretty dangerous, because what if this method thinks that this object is a string and I passed in an array and it's going to crash? And yeah, that's true. Luckily, there are ways in Objective-C to ask an object, what is your class? Or do you respond to this method? So that you can prevent yourself from crashing by asking that question first. And then you're going to see how we can take an ID and put a little bit of extra syntax in there to turn into a protocol, where it's any object that responds to a certain protocol. Okay? So I'm going to take off the foods app. So this is basically the starting public API of our model. I'm going to be adding a couple of instance variables I'll need in my implementation, but that'll be a little later. So now let's look at Calculator Brain's implementation. Yeah, question?
What is the negative sign at the start of the
Oh yeah, so he was asking, each of the methods had this dash at the beginning. That's either a dash or a plus, and I'm going to talk about what that means next week. But basically a dash means it's a message you send to an instance. A plus means it's a message you can send to that class. And that probably doesn't mean a lot to you right now, but next week it'll mean a lot. So for now, it's always a dash. We'll talk about plus next week. So this is calculatorbrain.m. It's the implementation of Calculator Brain. So it's going to have implementations of all those public methods, the two that we declared, and also it's going to have implementation of private methods that are only for us to use. Okay? We obviously have to import our own header file. Oh, I forgot to say, you see the @sign implementation, @end. That's similar to @sign interface, @end, except for this is our implementation. Also, notice we didn't put the colon NS object. We don't put our superclass here in the implementation, but we do have to include or import our own header file. And that's so that our implementation knows what our instance variables are and things like that. So this is what it looks like to put method implementation in. Almost exactly the same as the header file, but no semicolon and curly braces instead. Question? Yeah, the question is, do we ever need to use include versus this thing import? If you look at import, it kind of does all that magic includes for you, so that if you include something else, and you get these roundabout things, it manages most of that, not all of it, for you. So # import is the way we include header files in Objective-C. We never use include. You would never use it in your code. But it is a strict superset of C, so # include is there, it's just we don't use it. Okay, so back to this. Set operand, no semicolon there, but curly braces instead, and the code goes here. So set operand, for example, its implementation, no semicolon there. Its implementation, very simple, operand equals an operand. Okay, that's going to be the entire implementation of that method, super simple. We have another method. I'm not going to show you the implementation of that method in the slides. I'll show you when we do the demo. But I wanted to show you what it looks like to send a message. So we talked about declaring methods and objects, but what about sending them? And this is what it looks like. There's this kind of funky square bracket notation. Okay? You basically put square brackets at the beginning and at the end of your message send. All right? And the first thing after the square bracket is the object you're going to send the message to. Here I'm sending this message called send message : to the operation, which is this NS string star. Okay, so it's a string message. So this send message that I'm sending better work on strings, because that's what I'm sending, right? Sending send message to it. And then this is the argument that I'm passing along with send message : Okay, so I just wanted to show you that syntax. Obviously, our implementation of perform operation is going to have a lot of different stuff in there. Okay, so that's the model's header file, its interface, and now its implementation. The last thing I'm going to show you is the controller, its header file. We're not going to do its implementation, but we'll show its header file. So a couple things to note here. One is our controller inherits from a class in the iOS SDK called UIViewController. See it there? And that's why I'm importing UIKit, UIKit.h, which is the UIKit's master header file. The UIKit is a thing that has buttons and sliders and view controllers and views and things like that in it. So I have to import that because it's my superclass. Okay, so note that. UIViewController is how the UIKit plugs into your MVC structure. right? So MVC is part of how the UI kit expects you to do your work. It's not just a nice idea to make it work. It's actually part of how the UI kit expects you to behave. So this first instance variable, right? This instance variable in public header file here. Instance variable is our brain. This is, if you remember our MVC model, this is the pointer over to our model. Okay, and remember that our controller can talk to our model as much as it wants. So that's a green arrow. That's what that pointer is. Then this pointer, the display, as well as these two methods, are the target action thing, the little that we hung up, and also the green arrow that can go from a controller to its view. So the display is that green arrow that goes from the controller's view, and then these two methods down here are actions, the two actions that are being sent. So hopefully it's somewhat self-explanatory how I'm declaring it here. There is something interesting here, this IB action, you see that, an IB outlet. Okay, IB action is the same as void. It's exactly the same. The only difference is the interface builder program looks at your header files so that it knows which things are things that you want to wire up using interface builder. So it's the same as void. It's probably even type def to void somewhere in some header file. But you put it in there anytime it's an action you're going to want to wire up in interface builder, which we'll see in a moment. Same thing with IB outlet. Okay, that's void as well, but it's an indicator to interface builder that this UI label pointer is going to be something we're going to wire up using this interface builder tool. Now you see what it's going to look like in interface builder in the upper right hand corner there. That's approximately what our user interface is going to look like. And so we're literally going to be dragging connections from our controller to these various buttons and labels and stuff with the mouse in the interface builder. So on this screen is all three things here, the controller, the model, and the view. Okay, and you can hopefully imagine the connections to them. That's what we're going to do today. I want to show interface builder really quickly, just so that when I'm doing this, because when I do it, I'm going to drag it out and you're going to say, oh, what do you do right there? So I'm going to give you a little preview of what I did right there. The first thing to note is this file right here, which has my user interface mostly built. Okay, this thing is in a file called calculatorviewcontroller.zib. I have the name of the file in the lower left corner right there. You can also see it in the main window of interface builder, which is that small window at the bottom. So I told you that the view is like the minions of the controller. That's why we put all the views, including the buttons and subviews, into a file that has the name of our controller.zib. Sometimes that confuses people a little bit, but that's why we do that, because these things are the minions. They essentially are being driven by calculator view controller, which is our controller. One other thing to note is this little icon that says Files Owner. Very important to understand what that is. Since this is calculator view controller's minions, the files owner for this file, this in interface builder, is our controller. So anytime we want to wire something up to our controller in either direction, that's the icon we're going to use. Okay, sometimes people get a little bit confused. Where is my controller? I don't see it. It's the files owner in this file. All right. Now, let me talk briefly about these four windows here that appear in Interface Builder. These are the only four windows really you're going to see. The one in the left there, Library, that's a big list of all the objects in the UI kit and some other kits that you can drag out to build your user interface with. So you can see right there, we've got label and round rect button and a text field. We have a switch, a slider. These are all things we can just pick up with the mouse and drag them out into our view, our controller's view, to build whatever our user interface is, and we'll be doing that today. On the right, that window is called the inspector, and that, if you select any object in Interface Builder, it's just an inspector that lets you set all kinds of attributes of it. The contents of it change as you select different things. Obviously, the contents are different if it's a button selected versus a UI label or something else. And then the window on the bottom, that's the main window. That has a graphical representation of kind of top-level views, but also objects that don't have a visual representation, like your controller, files owner, right? They need an icon so you can drag lines between them. That's where they live. You can view it in different ways. This one right here is in a big icon mode, but you can list it kind of a list mode, and then there's like a browser type mode, like the Finder in the Mac, to find your objects. And when you have a big user interface that has a lot of stuff in there, it can be sometimes convenient to go find things in there versus trying to click around in them up in the middle window, top middle, and the top middle is our view. So we directly manipulate our view. You notice that that view is the kind of the aspect ratio of an iPhone. If we were doing an iPad app, it would have, we'd have a window that would be more iPad sized and ratioed. And so we literally just directly manipulate stuff into our UI, and I'm going to show you that in Interface Builder. So here's the connections we're going to make. First, we're going to drag from one of the digit buttons down to Files Owner, and this little black window is going to come up, and it's going to show all of the methods that we can send that make sense from a button to this Files Owner. And we're just going to pick digit pressed in this case, and it'll make that connection. Okay, we're going to do the exact same thing with the operation buttons. Okay, that little black window is going to come up. I'm going to pick operation pressed, and that's going to wire it up. Now, I'm not going to have to do this for every single button, because I'm just going to do it for my first digit button, and then I'm going to copy and paste it. Because copying and pasting in iOS Interface Builder keeps the connections, so it copies the connection as well. So any digit button that I've wired up and copy and paste, the new button will also be wired up to send that same message. And you might ask, how am I going to know whether I'm clicking on a 7 button or a 5 button? Well, remember that the message has an argument, UI button sender. So we'll know which button sent us, and we're going to write a little code to ask the sender, what is it that, what button are you? And then we'll be able to do our digit or operation from there. And then we also have one more dragging to do, which is we're going to drag from the Files Owner up to the display. And notice the direction you drag matters, because here we're dragging from our controller to our view, because we're making an outlet. But the same kind of little black window will come up. This one has different choices in it, display and view, because we're making an outlet. It doesn't make sense to we're not doing target action here, we're doing outlets. And so we'll pick display. We'll talk about what that other one, view, is. We inherit that from UI View Controller. We'll talk about that later in the quarter. Okay, so that's it. That's basically what we're going to do. So, a demo is worth 1,000 slides, really, is what I should say. And so we're just going to sit down and we'll do this thing. See how we're doing on time? Plenty of time. All right, so we start with Xcode. Now, I should say, let me show you where Xcode is going to land. When you install the SDK in Xcode, it's going to install this directory at your top level called Developer. All right, and if you look inside a Developer, there's going to be an Applications, and here's where Xcode and Interface Builder live. I kind of recommend that you create a Developer directory in your home directory as well, and keep all your projects in there. Okay, it's just kind of a nice consistency of naming. So you're just going to double click on Xcode right here, and you're going to get this splash screen. Now this splash screen on the right has all the recent projects that you've been working on. Okay, and we don't have any because this is our first project, but you can one click there and you're right into your project, very convenient. But then on the left, there's these 3 buttons right here, a little bit of help, how to get to developer.apple.com, basically the Dev Center there, and also creating a new project. That's what we want to do today. I'm just going to click Create a New Project. Now, when we create a project, Xcode essentially knows how to give you a template for a lot of different kinds of projects. In fact, if you had, for here, we could create a Mac OS X project, actually, a Cocoa application, which is for the Mac, not for iPhone. And then, command line tools, things like that. You can even create frameworks, libraries, even Cocoa Touch libraries. If you're building, a suite of applications, you want to have a shared library, you can do that. But what we're mostly interested in is this section, iOS application. Okay, these are templates for building iOS applications. And you can see there's some here, like building an OpenGL ES application, that'd be a 3D graphics application, split view based application for iPads. There's really 2 that we're interested in, which is these 2. Okay, window-based application is the most raw application. It doesn't have any MVC in there for you yet. You're going to build all that yourself in code. It's the most minimal application. We will actually be using this for our second series of homework, because we're going to be building a pretty complicated MVC picture, and so we're going to want to control that ourselves. But the one we're going to choose today, and the one you choose for a simple app, it's called View-Based Application. I wish it were called something like Simple MVC, because that's really what it is. View-Based Application template is going to create a project that has a controller and a view and you'll have to put your own model in there. So it's basically a single tree controller view model to start with. Now you can always add more controllers and views, you will, but this is a nice simple way to start. So let's choose that. It's asking for the name of it. By default, it's putting it in my developer directory, which is good. I'm going to call it calculator. I strongly recommend you call it calculator because if you're following along with the walkthrough that I'm giving you, everything is calculator this, calculator that. You'll be confused if you call this something else. Also, I recommend a capital C, and the reason for that is that it's kind of a naming convention that is universally used in iOS application, is that classes start with a capital letter, okay? And it's going to use the name of your project to build you a view controller template. Okay, I told you this was a template, Xcode, building you a little template for an app. It's going to create calculator view controller for you. So if you call this foo, it's going to create foo view controller. So you want to use calculator capital C here. So that's what I'm going to do. So now it's built this template and showing us now the main window of Xcode. You're going to be in this window a lot. This is where pretty much everything happens. Building, editing, debugging, the whole thing happens here. So let's take a little tour of this. I'm going to try and deal with the size of the windows to let you see as much as possible here. This area up here in the upper left, very important. This is where all your files are kept. And these little folders can be opened. So I'm going to open a few of them here. And you can see then all the files that are in your project. Now, some of them are like frameworks down here, like this project is going to use the UIKit framework, Foundation framework, and Core Graphics framework, which is for drawing, 2D drawing. And then there's other sources right here, like my main. This is basically a Unix executable at its heart, and so it has to have a main. The main is pretty simple. It basically calls a couple of objects to get itself started. Then here, calculator view controller.zib, that's our view. That's that little bag, that thing we showed you in Interface Builder. That's kind of our collection of view. It's empty right now. We're going to have to put some stuff into that. And then it created two classes for us right here. Calculator view controller.h and .m and calculator app delegate.h and .m. Now, calculator app delegate is a special kind of delegate. Remember I told you delegates are those things like will, did, should kind of delegation things going on, and that's what calculator app delegate is. But instead of being a delegate from a view to its controller, it's a delegate from the application object. So it lets you kind of control the operation of your application. So this one that it creates is kind of a stub, but it's got a lot of dids and wills in there, and we'll be looking at that a lot this quarter because there's a lot of stuff that you can control about how your application runs via your app delegate. But today, we're mostly interested in our view, which is this guy, and our controller, which is this guy. Okay? Now, what about our model? We need our model. And of course, it can't really create that in the template because it has no idea what the model might be. So we're going to create that by going here to File, New, create a new file. And again, you can create different kinds of files. You can create a new UI view controller subclass or a protocol, an Objective-C protocol if you wanted to. We're going to create an Objective-C class, and it's going to be a subclass of NSObject. You can see right here. Click Next. Now it wants to know the name. We're going to call it Calculator Brain. I apologize for my mistyping. This keyboard is not my usual keyboard. So there's Calculator Brain. So now we have our Calculator Brain. Notice it kind of put our Calculator Brain in between our two things here. We can just pick these up and drag these around. Okay, you can even drag them between different little folders if you want to arrange them. But here's our Calculator Brain. Now, there's no implementation of the Calculator Brain or anything like that, but at least there's a stub there for it. So we're going to put aside implementing our Calculator Brain, and actually we're going to do our header, our public API, of our Calculator View Controller. Okay, so I'm going to click on that. You can see it brings up our View Controller. I'm going to make some more space for it right here. And it's already put our superclass and an import for that, so that's convenient for us. So let's just add our outlets and actions, you know, our connections from our controller to our model and view, and then also the actions are going to be sent from our view. So let's start with the connection from our controller to our view. So it's an IB outlet. Remember I told you we're going to put this kind of magic word in there, and it's a UI label called display. That's going to be wired up to be our display in our calculator. Then we also, though, need another outlet to our model. So that's calculator brain. I'm going to call it brain. That's what I'm going to call my instance variable. Now I need to import my calculator brain header file here because I can't reference classes that I don't have a header file for. Notice that it's kind of escape completing as I type. Xcode is really nice about this. You start to type something, it's going to start escape completing it, and you can just use tab to tab over. Especially if you have a long method with a lot of things, it just jumps you to each variable. Very, very nice. Makes it really easy to type very quickly, and also not make mistakes. So that's my instance variables. That's the only instance variables I have for now. So now let's put those IB actions in. So I have IB action digit pressed, which is going to have a UI button sender as its argument. And I have an IB action operation pressed, which has a UI button also, sender. So this argument to our IB action that sent is the object that's sending us the message, which is really convenient. We really need that in this implementation. Actually, I could build and run my application right now. I could have built and run it before, but let's go ahead and build and run it. Now, I don't have a device connected, so what's going to happen when I build and run is it's going to run a simulator. All right, and you can see here's our little iPhone simulator. It's simulating the running of an iPhone. There's also an iPad simulator as well. And you can see that our application runs. It's great. Has no user interface. It doesn't do anything. I can't touch on it. You obviously touch by using your mouse in the simulator. The simulator, is really simulating the phone. It really, you can do all this business. Doesn't have a lot of the stuff, but you can do settings and things like that. It's kind of fun. And so you will only need the simulator to do your homework. When you do your final project, you're going to want to get this working on the hardware. But for the homework, you can do it all in the simulator, either the iPhone or the iPad. Some of the homeworks require iPads, some iPhone. Okay, so I'm going to quit the simulator, go back here. Before I go on, I want to take a look at this little thing right down here. Maybe I'll even zoom in. You see this corner right here, this little yellow arrow with the 3? Those are warnings. Okay? That means there's something wrong with my code. Not so wrong that it can't build and run, but something I need to pay attention to, okay? So I'm actually going to click on that and see what it says. So when you click on that little yellow thing, it's going to bring up another window that shows you these warnings. And indeed, these are real warnings. It says method definition for operation pressed, not found. Well, that's because I haven't implemented operation pressed. Now, it can go ahead and run with that situation being there, but if I ever tried to send operation pressed to my controller, it's going to crash, okay, because that method is not there. It's in the header file, and just because it's in the header file doesn't mean it's implemented. So here it's trying to warn me against future disaster. This is why in your homework, we don't allow you to submit projects, or you'll be docked if you submit projects that have warnings, because usually those warnings are foretelling impending disaster, okay, or there's something that you didn't quite do right. So definitely pay attention to those. If this little yellow thing were red, then that would be a build error, and that would prevent your program from running. Okay, so that would be like a syntax error, can't parse your code, and again, it would tell you what it was. It's similar to other C compilers. Sometimes the errors can be somewhat obscure. If you left a semicolon off the previous line, it's trying to figure out what exactly you meant by that, but no different really than other ones, and in some ways better. So that's that. The next thing we're going to do, now that we have our calculator view controller's public API, its outlets and action set up, is we're going to go into Interface Builder and build our UI. Okay, so how do we do that? Again, very simple. I told you that this thing here, calculator view controller.zib, was our view, so I'm just going to double click on it. And you can see at the bottom, it's flashing Interface Builder there. I'm using spaces, which I recommend, to have Interface Builder open up in a different space. That's because Interface Builder has a lot of windows kind of overlapping, and it's easier to see what's going on. Here's the 4 windows that I showed you in the slides. And since I've kind of explained all this, remember Files Owner, that's our controller, I'm just going to start building it. Okay, I'm going to start with a button. So I'm just picking a button up out of the library and dragging it out here. Now, notice these blue lines. Okay, this is Interface Builder trying to give you a little gravity to help put them all lined up, or nice spacing on the screen. Like for example here, you want it far enough for the edge so that someone's fat finger touching it will not miss it or hit the edge instead. So they've kind of picked some really nice spacing to make things work nice. Now I need 4 of these buttons across, so I'm going to actually make my button a little smaller. And again, I can do that direct manipulation. I just grab the little handles and resize it. I also, to put something on it, like let's make this the 7 button, I can just double click and type 7. Okay? I could also use the inspector. You're probably noticing on the right that as I click a button, I got an inspector that's inspecting things. We'll look at that in a second. But the most important thing I need to do with this button is wire it up to my controller. So right now, I am holding down the control key on my keyboard, and then I am dragging from my button to my file's owner. Okay? So notice as I get close, it's like, ooh, it gets highlighted there. Okay? So when I let go, that's when I get this little black window. And 7 is one of the digit buttons, so I'm going to click digit pressed, and it flashed there quickly, and so it's done. It's wired up. So every time I touch this 7 button in my running program, it's going to send digit pressed, with the sender being the 7 button, to my file's owner, which is my controller, my calculator view controller. Everyone got that? So I need a whole bunch of buttons, so I'm going to use copy and paste here. Again, it's helping me with the layout. I can even go like this. Copy, paste, paste, some more buttons. Let's grab one, copy, paste. So here's my keypad layout, basically, all my digits. That was easy. I'll change the numbers to be the numbers I want. We're obviously going to find out which button we pressed by looking back at the title on our button, which you could argue whether that's a good design or not. When you start talking about localization and things like that, it might not be so good, actually. But it's really simple code, and we're trying to do something simple, so there's a few lines of code for you to try and interpret as possible. Now we need operation buttons: times, divide, plus, minus, square root, equals. So I could copy and paste a digit button, but that would be bad. And that's because I would end up with a button that was sending both digit pressed and operation pressed. Okay? You can definitely have buttons that send 2 messages, and you don't want that. That would be very confusing to our controller. So I'm going to drag out a new one, set it here. I'm going to make it 64 wide as well. And this one, I'm holding down Control again, dragging to my controller, letting go. This time, operation pressed. Okay? So now this button is going to do that. I could put the times on there, let's say. Again, I can copy and paste, 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 paste. Oops. Over here, paste. I'm leaving a space down here for square root intentionally because your homework is going to put a particular kind of button right there, I think. So I'm leaving space for you. Oops. You can undo, obviously. I just undid there because I misclicked. So let's do square root right there. Let's do divide. Let's do plus. Let's do minus. And we're going to do equals. OK, so that's all our buttons. They're all laid out. They're all set to what I want them to look like and what they have on them. They're all set to send messages to my controller. So I'm done with those. The last thing I have to do is my display. Okay, so that is a label. Label, which is the class UI label, which you can see down here actually. Whenever you click on something in the library, it's going to tell you the class of it. So here's the UI label. Label is static text, okay? Output only text. You can't edit it. It's not editable. There's another class down here, text field for input text. Maybe I'll give you a little idea of how big this library is. We got date pickers, advertising banner view, map view, a web view showing images, tables, even other view controllers here, navigation controllers, tab bar controllers. And this is a very, sliders, but switch. There's a very extensive library of things to choose from here. But what we want is label, so I'm going to pick that up, drag it up here. We can try and resize it to what we want. I don't really want it to say label when our interface starts, so I'll change it to say 0. Now, this is really not what I want either. First of all, calculators, the numbers come from the right? They grow out from the right. So I need this thing right aligned. Also, it's too small. I want it to be pretty big, the numbers to be big. So let's use the inspector here so we can see how that works. So I have the label selected, right? There's a button selected. Here's the label selected. And you look over here and you can see that in the inspector, the leftmost tab, it's showing all the attributes of a label. Notice it's also inheriting all the attributes of a generic view, because a label inherits from view. So the inspector is nice in that it works in an object-oriented way. As things are subclassed, the inspector picks up all the attribute setting. So here I want it to be right aligned. And I also want to change the font. So this brings up a standard font chooser here. I'm going to go pretty big, let's say 36. Yeah, looks good. Maybe I'll do a little more sizing here using the blue lines rather, something like that. Okay, so that looks good. I'm happy with that. Now all I need to do is set that last outlet, the connection from our controller to the thing in the view we want to talk to. And I just do that by Control. I'm holding down Control and dragging up, okay, to the display. Let go. And here's the, as promised, little black window. I'm going to hook this one up to display. All right. So now, anytime I have an instance variable called display, you'll remember every time I want to send a message to my display, I can just send a message to that object. It's going to get sent to this object. Does that make sense? Okay, great. So that's it. We're done. Our view is completely finished here and completely wired up to our controller. So we can go back to Xcode. We could run our application right now. So I'm just going to hit this build and run. And there it is. Now, what's going to happen if I click on one of these? Yeah, it's going to crash because we'll be sending digit pressed to an object that doesn't implement it. Okay, it's in its header file, but it has no implementation. So we'll try it. Click, crashed. Okay, our application crashed. So that's no good. So the simulator didn't crash, our application crashed. All right, so what next? The next thing I want to do actually is take a break from our view controller. We'll go back and implement that. Let's implement our brain first, because obviously our controller is going to want to use our brain to do the calculations. So let's implement our brain. Okay, let's do the implementation of our calculator brain, which is this guy right here. So what instance variables do we need from our calculator brain? First and foremost, we need our operand. It's the same as I said on the slides. That's really all we need for now. I might need another instance variable in a minute, but for now, that's fundamentally all I need. And then the methods that I told you we were going to need are setting the operand and also performing the operation. Okay. Now, notice that the operation is specified as a string. Now, we're going to be really tricky here and just use the string that's on the buttons, which, again, in a localized world, I'm not sure sqrt means square root in, German. Probably some really, really long named thing. So we would probably want to use some other mechanism, but we'll go short circuit here. And really, I believe that the way we're doing it is a violation of MVC. Even though the view is not sending any message directly to the model, the view and the model are making an assumption that, about what these strings mean that's shared, that's a little questionable. But again, for expediency of doing this demo, we're going to have the strings mean the same thing. The string on the button means the same thing as the operation we want to perform here. Now, I'm going to copy and paste. Okay, I'm selecting my two methods and copying them, and then I'm going to go over to Calculator Brain and paste them. Okay, but I'm going to get rid of these semicolons and put my curly braces in instead. Okay, for my implementation here. Yeah, question? As I said, all the objects in Objective-C are allocated on the heap. So you can only have pointers to them. Okay? It is only possible to have pointers to them. You can't allocate them. I couldn't say inside of a method NSString S. I'd have to say NSString star S and then allocate it. And we'll talk about next week how you allocate objects out of the heap. We're kind of waving our hands on that today. Actually, I'm going to show you today, but I'm not going to spend much time on it. But anyway, so that's why we always have NSString star, NSArray star. It's always a star. All right, so that is our kind of basic implementation here. How are we going to do our calculator brain? Set operand is easy. That's just operand equals an operand. So here I'm just taking my operand, which is a double instance variable, and I'm setting it to the argument that was passed in there. Okay, that should be pretty self-explanatory. Next, let's do perform operation. I'm going to do square root because it's a really easy one to implement. Okay, so I'm going to say if. Now I'm going to send a message here, square bracket, operation. So I'm going to send a message to the operation string that was sent in. And I'm going to ask it, are you equal to the string square root? Okay, so @ quote square root creates it creates a string object, an NS string star. The compiler creates it for you. It's kind of it points to a constant data somewhere, but you don't know that. But it's just like any other string. Okay, it is no different than any other string. It looks funny, I know, to write it that way, but don't forget that little @ sign at the beginning. If you don't put that @ sign there, it's a const char star. Okay, like a C, const char star. And if you are passing that around as an NS string object, that's not going to work, okay, because it's not an object. It's literally a const char star. So when you start programming on iOS, you'll forget that @ sign quite a bit, okay, but you got to remember to put the @ sign in when what you want is a literal constant string. So there's square root. So if it is equal, what are we going to do? Well, I'm just going to take my operand and make it equal to square root, C library function of operand, my current operand. So my calculator brain has an instance variable which is its current operand, and all I'm going to do if the operation I'm asked to perform is square root is just take that operand, take the square root of it, and make that my new operand. And then I told you that I was going to return my current internal operand from this method just for convenience of the caller. Okay? If I didn't do this, I'd have to have another method called basically get operand that the caller would have to then call to get the operand. This way, it's a little easier for them. So that's single operation, real easy peasy, and you can imagine adding all kinds of single operations here. Let's talk about multiple argument operations like times, okay, and plus. Now, I could have done a reverse Polish notation calculator here, and this would have been a lot easier because I just have this stack of numbers and I just start pulling them off 2 at a time as I was doing times and plus. Instead, we have this normal calculator where you say 3 times 5 equals, or you might even say 3 times 5 plus 6 equals. And so when is the operation actually happening there? Because when I say 3 times 5, the operation doesn't really happen until I press another thing, like equals or plus or something else. So we kind of have to have our operation, that times in 3 times 5, waiting around until another operation gets performed. Then we can go back and perform it. So it's, you see what's going on there? Kind of goofy, but not that easy, not that difficult to code up, but just maybe a little difficult to understand what's going on. But anyway, so I'm going to say else, meaning if it's not the single operation square root, and if I had other ifs, I could do if then else, if then else. This all looks like C, hopefully, to you or similar to it. I'm going to say self. I'm going to send a message to myself perform waiting operation. Now, I'm intentionally putting this in another method because I wanted to show you A, how to make a private method, and B, how to send a message to yourself. Okay, now hopefully this line of code is pretty straightforward. It's square brackets on both sides, so I'm sending a message. The object I'm sending a message to is myself. That should make sense if you're no object-oriented programming. And the method I'm sending is perform waiting operation. It has no arguments. Okay, that method has no arguments. So it's going to have to use some internal instance variables to do what it does. Now, so this is going to perform any operation that's kind of waiting to happen, like the 3 times 5, the times that's waiting for its next operand to get entered. But we also here have to record the current operation because it starts being the waiting operation. So I'm going to say waiting operation, which is going to be a new instance variable, equals operation. And I have to keep track of the operand, waiting operand equals operand. Okay? So I'm going to have 2 instance variables I'm going to add, waiting operation, waiting operand. They're just going to keep, this is 3 times 5 equals. This is going to keep track of the 3 and the times. Okay? So that when the person goes 5 equals and the equals happens, or they go 5 plus and the plus happens, we can go back and use that waiting 3 and waiting times, multiply it times the current operand, which would be 5, get the result. Okay? So let's add those instance variables back here. So waiting operation is a string, operation, and waiting operand is a double. Okay? So that's that. So all we have to do now is implement our perform waiting operation private method. One thing to notice about the private methods is they need to be declared in your implementation file before you use them. Okay, if you don't, you'll get warnings from the compiler because it, typical order of compilation issue. So here I'm going to say void perform waiting operation. Okay, it's void, doesn't return anything. What does this method look like? This one's also very simple. I'm going to throw a little curveball at you here just so you can really believe me about strings. I'm going to say if plus is equal to the waiting operation, then I'm going to say my operand equals my waiting operand plus my operand. Okay, notice there I've taken that string literal, @plus, I sent it a message. And it's in a string just as much as waiting operation is. I could have put it the other way around. I could have sent waiting operation the message, right? Asked it if it is equal to quote plus. But I can also send a message to @plus saying, are you equal to waiting operation? Okay, I just want you to make sure you understand that strings are real objects. Okay, they're created for you, but they're real. All right, so let's do our other operations here. Minus is equal to waiting operation. I might do some copy and paste here if you don't mind. So that would be operand equals waiting operand minus operand. You got to be a little careful of the order here, but I believe this is the right order. We'll do some copy and paste here for the last two. Copy, paste, paste, paste. Let's do times is times. Some of you are saying, ooh, divide. What's going to happen with divide? Because if I go like this, what happens if operand is 0? That's going to crash. Okay, that's divide by 0, not allowed. So I'm just going to silently fail. If we were writing a real calculator, we'd want to put up an error message or something. But I'm just going to say, if operand, then do this. Otherwise, just do nothing. Okay, so that's not very good coding, but I only have so much time today. All right, so this is the implementation of our calculator brain. Pretty straightforward. Okay, we can build and run at this point, make sure we have many errors. Look, there's all kinds of errors here. Why is this? Well, because I forgot parentheses there, so let's fix that. You can see these red errors will tell you in line, like expected parentheses before square bracket, which is really convenient. You don't have to go to that build results window if you don't want. So we'll try that. We'll build there. I still have another one here, which is, what did I do wrong here? Expected semicolon before open square bracket. Oh, else if. How about that? If. So you can see that it takes somewhat of skill to interpret compiler warnings. Okay, so now I build, and it's succeeded. Build and run. By the way, I was hitting there build, which is not build and run, but just build. I'll show you where that is in a second. Again, if I press a button here, crash, because I still haven't implemented my controller. I've only implemented my brain. Okay, and the controller's not using the brain yet to do anything. Here's where I did the build. It's right here, Command B. That just builds your program. Build and analyze is kind of fun to play with. It actually builds your program and tries to look at the code to make sure code paths make sense. So that's kind of a fun one to play with. But anyway, so there's our model implemented. The last thing we need to do is to do the implementation of our controller. So that's pretty straightforward as well. So let's go to controller right here. Here's we don't need to change our API. It's everything we need. I'm actually going to copy and paste these two method declarations into my implementation, just like I did with my brain. You notice all this commented out stuff and that's in here in the controller. You don't need any of that for this assignment. In future assignments, some of that stuff you're going to uncomment and actually use. But here we're just going to select it all, delete it, and I'm going to paste in those methods. I'm going to put my curly braces in here, just like that. Okay? Oops. Save all. All right. So how about the implementation of this? What's required here? Let's start doing the operation. Okay, we're going to start with the implementation of that one. The first thing we need to understand from the operation is which operation are we doing, right? So we got sent this message from a button. We're in our controller. The view sent us this message using target action. We're the target. It sent this action to us. Which, operation got pressed? Well, the way we're going to find that out is we are going to send a message. I'm going to have a local variable here, which is a pointer to an operation. And I'm going to send a message to an object that is returned by sending another message to find out. Now, what's happening here with this nested message sending? Okay, this message right here, sender title label, sends the message title label to the sender, which is a button, right? Sender is UI button right here. Buttons, when they draw their text, they actually use a UI label to draw their text. which is kind of nice object-oriented reuse, I think. And so if we want to get the title of a button, we ask it for its label, its UI label, and then we're going to send a message to that UI label saying, what's the text on you? And that's what this message is. Now, this kind of nesting of message send inside message send, super common. In fact, you want to code that way. It's not like, oh, this is making unreadable code. And in fact, if you read this from left to right, it says a string, which is operation, is equal to sending the sender title label and asking it for its text. So you can kind of fill in some prepositions and words and read this left to right, and it'll read just fine. You could, of course, separate this into two different lines of code and all that, but this is generally the way you would code this. Now, the next thing we need to do, we have our operation. We need to tell our brain to perform that operation. All right? But where is our brain? We have this instance variable for it right here, but we don't ever actually create it. It doesn't actually exist. All the stuff in our view got created by Interface Builder, but our brain doesn't exist. So we need a method, and I'm going to add a method at the top of my implementation here that returns our calculator brain, just for convenience. I'm going to call the method brain, same thing as my instance variable, which is perfectly fine. I'm going to say if my instance variable brain is not set yet, and it's perfectly fine to check object pointers implicitly with the exclamation point saying not. Okay? If it doesn't exist, then I'm going to create it. And this is how you create it. Don't worry about this syntax. We'll talk about this later. And then I'm just going to return my instance variable. So this is a method lazily instantiates our model from our controller. This kind of lazy instantiation is pretty good programming style, especially on an embedded device. An iPhone, the memory is not unlimited there. You definitely want to not create memory until you have to. So this kind of lazy instantiation, really valuable. Now, how do I use this in a line of code? How about this? Double result equals self brain perform operation. Okay? So here, I'm using the nesting again. I'm sending self brain to myself. It returns my own instance variable called brain and creates it if necessary. And then I send it perform operation with the operation which I got from the title labels text from my sender. Make sense? What's going on here? Good. So now I've got the result. I need, by performing the operation, now I need to update my display. Conveniently, I have that outlet that I created called display. And so I just say display, set your text. It's a UI label, so it responds to the method set text. And I'm going to create a string version of that double using a kind of a utility method message that I can send to the string class, which is string with format. %G, same kind of format that you'd see in printf, basically. Just like that, okay? So everyone got these three lines of code? I'm basically just getting the operation, performing the operation in my brain, because it's the thing that, it's a model, it's the thing that does the work, and then I'm setting the result in my display. All right? Now, there's one kind of weird thing here, though. If I type 345 times, when does that 345 become the operand of my calculator brain? Never. I need to call set operand somehow. Okay? So when do I call set operand? Well, certainly every time the operation is pressed, I want to take whatever number's in the display and make that be the operand. Okay? But there's kind of two states. If I say 3 times 5 plus 4, then there is no number being entered. Okay? It's the previous result. So I kind of need to know in my controller whether I'm in the middle of typing a number. All right? So I'm going to have an instance variable called if user is in the middle of typing a number. Now, you might laugh, like, whoa, what kind of instance variable name is that? But actually, it's a good instance variable name because we're trying to write code that reads like English. So if I say if the user is in the middle of typing a number, then I'm going to say self brain set your operand to be the display's text converted to a double. Okay? And of course, if that happens, then I'm no longer in the middle of typing a number. I just set the operand, so user is in the middle of typing equals no. Now, I also need to add this as an instance variable, so I'm going to go back to my header file, And I'm going to make this a bool. So there is no Boolean when ANSI-C. When Objective-C was created, there was no Boolean type. So Objective-C called it bool. User is in the middle of typing a number. It's too bad it's not helping me more there. But it did notice that that is used somewhere else. So that's simple. You kind of could ask the other question, which is, we're setting it to no here. Where does it ever get set to yes? Well, it gets set to yes anytime you start typing digits. Because as soon as you start typing digits, now the user's in the middle of typing a number, right? So up here in digit pressed, we want to have if the user is in the middle of typing a number, then the display wants to be updated by setting its text to the current text in the display plus a string by appending string the digit the person typed, which we have to get from the sender, which we'll do in a second. More square brackets. Otherwise, if we're not in the, and of course, so if we're not in the middle of typing a number and someone types a digit, then the display just wants to be set to that digit. And now user is in the middle of typing equals yes. Okay, bools types are yes or no. Now, the only thing we have left to do is this digit thing. Okay, I've used this variable digit twice here, but I have to set it. It turns out to be very easy to set. NS string start digit equals sender title label text. Okay, when digit press gets sent to us, the button that's sending it, its title labels text is the number. Make sense? So all we're doing here, getting that title number and just appending it on to what you've typed so far, unless you're not in the middle of typing something, in which case we start. Everyone cool with that? If you're not really getting that logic, you can stare at that code offline. It's pretty straightforward. So we're done. I believe that's it. And our program should work entirely. So let's build and run. Oops, we have errors. Let's see what our errors are. Okay, you need a square bracket. There we go. And build and run. All right, so this is where you cross your fingers, pray for the poor instructor. Let's try 5 times 9 equals. Oh, look at that, it works. Divided by 6, 7.5. So our calculator even does floating point. And plus 3 equals, or we can start over, 2 plus 6 equals square root. Okay, so real simple. Hopefully not a lot of code to pour through to understand how that works. And hopefully you understand where the view is, where the controller is, where the model is. All right. Now let me talk briefly about your homework. So your homework is, first of all, to build this. Okay, and that's mostly so you get experience with Xcode and Interface Builder and wiring things up, writing the code, getting used to the syntax of sending messages a little bit. So that's part A. And then part B is that you're going to extend this. Now, one of the ways you're going to extend this is you're going to allow entry of floating point numbers. So 5.7 times 3 equals. Okay. You're also going to add a few more operations and a couple other things, but that's generally what you're going to be asked to do. The homework and the walkthrough, I told you there's a completely detailed walkthrough of everything I did today. That's all posted on the website, and the homework is due. It's assigned now. It should be up there now, and it's due next Wednesday by the end of the day, meaning 11:59 p.m. for those who are exacting about those things. If you have any questions, feel free to ask me or any of the instructors by email or whatever. And next week, we will go into great depth about Objective-C, and we'll be in the homework extending our calculator to do even more cool stuff. So that's it for today. Thank you.
For more, please visit us at stanford.edu.